The sun is one of the greatest sources of energy on the planet, and solar cells are a good way to convert these energies into electricity. Solar cells are clean and non-polluting and are incredibly important in our fight against climate change. In this video, we'll take a look at exactly how the new generation of solar cells work. Solar cells, also known as photovoltaic cells, were first developed in the 1800s. Early solar cells were made up of individual materials that were combined together to produce electricity when exposed to sunlight. In the 1950s, silicon solar cells emerged, which were much more efficient and allowed for drastically increased electricity production. However, a new generation of solar cells have emerged. Here's all about it.
Explanation now.
What exactly are solar cells? A solar cell is a device which converts the energy of light directly into electrical energy. Solar cells are made up of layers of semiconducting material, usually silicon, that have been specially treated to generate an electrical current when exposed to sunlight. When photons from the sun hit the semiconducting material, they transfer their energy from the crystalline structure of the silicon, exciting electrons and raising them to higher energy states. This creates what is known as an electron-hole pair. The electrons can then move through the semiconductor material, generating an electrical current. This current is used to charge batteries or send directly to an electrical grid as an electrical output. So, how do solar cells actually work? In the coming minutes, you'll discover that solar cells are made up of a number of layers of materials. These layers are composed of two types of materials, usually a p-type layer and an n-type layer, forming a p-n junction that creates a built-in electrical field in the solar cell.
Lined with specialized polymer solar cells.
How do solar cells work? Solar cells are made of semiconductor materials, usually silicon, which are combined with other materials such as phosphorus and boron to form a p-n junction. This p-n junction creates a built-in electrical field in the solar cell. When sunlight strikes the solar cell, some of the light is absorbed and the energy is transferred to the electrons in a process called the photovoltaic effect. This energy causes the electrons to move, creating a current that is captured and collected by the circuitry in the solar cell. The photovoltaic effect varies depending on the type of semiconductor material being used. Silicon, for example, is able to absorb more energy from sunlight, allowing higher efficiency.
Boy, silicon!
On the other hand, the current created by the photovoltaic effect is direct current, or DC. This current is then converted into alternating current, or AC, by an inverter. The AC power is then used in household systems, industrial machines, and other applications, such as lights, batteries, pumps, and chargers. To help you stay ahead of the curve, we'll keep updating you with all the knowledge and insights on solar energy. So subscribe to this channel to stay up to date with the latest advancements in solar energy. Since solar cells do not emit any type of pollution, they are an environmentally friendly source of energy. As a result, more and more people are turning to solar power for their energy needs. In addition, solar cells offer a number of advantages, such as being affordable and reliable, making them a great choice for many applications. But the question is, how efficient are they? Aside from lessening our reliance on non-renewable energy sources, you'll learn why solar cells are becoming increasingly popular in the coming minutes.
Popular.
A new generation of solar cell. The latest development in solar cell technology is the polymer solar cell, PSC. PSCs are made from polymers, organic molecules that can be engineered to form thin films. They offer a number of advantages over traditional crystalline silicon cells. PSCs are flexible and lightweight, making them easier to install than traditional cells. They are also cheaper to produce and require fewer raw materials. This means they can be deployed at a lower cost. In addition, PSCs are more efficient than traditional solar cells. This is because polymers can absorb a broader range of light than traditional semiconductors, which means more of the sunlight is converted into electrical energy.
Energy.
How efficient are solar cells? Solar cells are increasingly becoming a popular way to generate power because they are clean, sustainable, and reliable. Solar cells reduce our dependence on non-renewable energy sources like coal and oil and can provide a steady source of renewable energy. Bonnie Raitt has said that solar power is the last energy resource that isn't owned yet. Nobody taxes the sun yet.
Solar powered.
However, solar cells are extremely cost-effective. The initial cost for deploying solar cells can be quite high, but the cost of operation and maintenance is relatively low. This makes solar cells an attractive option for people who want to reduce their energy costs. Additionally, solar cells are a clean source of energy that do not emit any dangerous emissions into the atmosphere. This is particularly important in areas where air quality is an issue. Solar cells offer the potential for a clean, sustainable, and reliable source of renewable energy. With the development of PSCs, the cost, weight, and efficiency of solar cells are now more attractive than ever before. With continued research and development, solar cells can play an important role in providing clean energy in the future.
Sustaining clean energy.
With great energy storage capacity, more efficient designs, and improved performance, the future of EVs looks brighter than ever with the next generation of battery technology that will revolutionize the electric vehicle industry. If you're looking to find out more, be sure to check out these next-gen batteries that will change EVs. Thank you for watching this video. Until next time, goodbye.